Hello, hello, hello. There's Colin. All right. Good morning. Good morning. There's Brandon. Good morning. Brittany.
Morning.
Good morning. Morning.
Morning.
With the voice even. That's awesome. Good morning. Good morning. And good morning, Shaynell. And and here's the and good morning, Alexis. Right, okay, more people. Hold on. And good morning, Maria and Charlotte. And there's Ariana and Xavier. Good morning. Awesome. Nasreen. Awesome. Good morning. This class is amazing. Did I say Xavier? Did I say and Anissa? Good morning, Carolina. Whoa, Carolina. Yowza. Okay. Good morning. Good morning. And now the chat. Did I say the chat? Hold on. Good morning, direct chat person. Good morning, Anissa. Good morning, Brittany. Good morning, Charlene. Good morning, Carolina. Good morning, Chanel. Good morning, Adenelsi. Good morning, Ryan. Good morning, Maria. Good morning, Alexis. Good morning, Ariana. Good morning, Nasreen. All right, I think that, okay. Also, wait, quick, hold on. Quick, 1 second. I'm checking. Oh, wait, no, there's someone else here. Hold on. We'll get rolling in a second, but there's also, um, one issue. Yes. Oh, I see. Okay. Okay. Give me 1 second, like a direct chat thing going on here. And if I didn't say good morning to you yet, I apologize, but I think that's everybody. Okay, give me 1 second. Hold on. And there's direct, okay, there's direct chat things happening. Give me 1 second. Um, okay. Yes. Oh, okay. No, I'm responding to direct chat. Give me a second, but that's totally appropriate. Hold. Okay. I think we're ready to go. Okay. I mean, for sure, if there's any other, we haven't seen each other for a while. And we're still getting to know each other. So for sure, if there's any questions at all about like anything, particular like how the class works, obviously, again, my thing is like each class we're hopefully spending more time on direct physics, and less time on how the class works. But that means publicly. I expect there to still be. You can still ask questions at any time about anything. I mean, and if you're at all worried with if it's going to interrupt the flow, put it in the direct chat, and then I'll figure it out. For real. So great. Thank you, direct chat person who just responded to me. Thank you. That's awesome. So one thing is because it's like the schedule has been so funny, it's sort of an unusual schedule, um, and I didn't realize it at the beginning of the semester that we had more more unusualness, I think, than usual. So I apologize. So a lot of those homework assignments were assigned faster than the class has been progressing and faster even than I meant. Um, so a couple quick things on that. I mean, in a minute, we're going to get back to homework two, which is where I feel that we are in going over the class and going over the material. Um, um, So first of all, things like homework 3 and 4, I've now just now I realized like, oh my God, homework 3 was already due last week and homework 4 is due tomorrow or something like that. So I've readjusted the dates so you could take a look when you get a chance. If you could see the dates have now been readjusted to meet where we are. But let me say, so hopefully that will help many of you or help you feel calmer or feel like we're on a similar page. But then a couple more quick things to say about that. It will always be true, and it'll be more and more true. It will be true that I ask you to do homeworks, solve problems, and think about things before we've discussed them in class. Like that is true in physics. It is true that it's like I guess some people now call it a reverse classroom or a backwards classroom or something, but we've been doing this in physics long before it had a name. Um, I don't want you to be surprised or shocked as the material progresses. Oh, and especially as we get into physics 204, like, yes, you are asked to think about things and then we go over them, not the other way around. That's the deal. And that's why, as long as you hand in a rough draft, a first draft, you can always readjust and revise your material later for more points. But I don't mean for you to be working on things like 3 weeks ahead of where we are. So that was too extreme. Hence, I've adjusted the dates. But the other thing is, you might have noticed, I don't want to punish anybody who did take the dates seriously or who assumed, that the class is the class. No, I hope you also notice that if you're any of the people, like everybody still has a chance to do homework, whatever it is, homework 3 and homework for average acceleration and big old duck. But if you're one of the people, and there are many of you, who just took the date seriously and did your best and already turned in average acceleration and already turned in midpoint velocity, you will notice that you've already gotten a huge number of the points just for doing that. I hope you see that. You haven't necessarily gotten feedback, but you've gotten a certain number of points that is not only most of them, just for the fact that you're keeping yourself ahead, not behind. And I want you to know your efforts are not wasted, but also the exact number of points you got, which we won't, is a signal to me to remind me when I get the others in and I get back to you later that you got it in particularly early. So we don't want any of you to think. So it's all going to work out for everybody. If you haven't done average acceleration homework yet or midpoint velocity because you had no idea how because we haven't even finished going over homework 2, I totally get it, and you won't be punished for lateness and you can still get all the points. But if you are one of the people that have done it, believe me, it's noted, and you're just ahead of the game and you're saving yourself more efforts for later and you're getting points faster. So, okay, so hopefully everybody feels that I see what you're doing. I mean, that's basically what I'm trying to say. And I still owe you a ton of feedback. And some of it you'll just come in the form of class instruction. All right. So that's what I'm trying to say about the big picture. In a minute, I'm going to turn back to homework. And last thing, I also don't want you to think, I mean, once we really get a rhythm and we start having class 2 times a week and stuff like that, it's not that I'm going to go over every single problem in every class. I'm not going to do that. But right now, I'm trying to, eventually we're going to sort of skip over more straightforward stuff and just get answers and talk about the harder stuff. But we're not at that stage yet. So, I'm going to, okay, so in a minute, my goal is to break down that hill figure problem of homework 2, which I think I like gave the answer and said some quick comments about last week, but I'm going to say it in more detail. And there's more than one way to solve it. So I definitely encourage you to follow what I'm saying. And then if you think, wait, I did it a different way, but I still got the right answer, whatever, feel free. Like chime in. Let's definitely make it a discussion. If you did it a different way, but got a different answer, well, then that probably means your way maybe has a flaw, but we should make sure we're both clear on what that is. So let's have a discussion in a minute. But now, so I'm going to turn to homework 2, to the hill figure problem. But before I do that, I'm going to look in the chat because I have a feeling something's happening in the chat. All right, so hold on. So. Wait, okay. Um, wait. Okay, I'm looking in the chat. I mean, some of the things are public, but some are private. So the thing about having you in the trenches, I think is hilarious. I'm not totally, wait. Oh, oh yeah. Oh, okay. That's actually kind of what I thought you meant. Okay. So really quickly again, any of you who like killed yourself to do these homeworks that were sort of hard, and I think they are, by the way. Let me back up also. I think whatever I've said in class or not said in class, in my opinion, oh yeah, by the time we get to, is it whatever average acceleration is, whatever that home, I think that's homework 4, right? It's a big leap from homework 3 to homework 4 in my mind, whether we've talked about the stuff in class or not. It is like once we're hitting homework 4, we're like, then things are kind of intense. So if you're not, and certainly homework 5 and homework 6, etc. So if you are one of those people that already killed yourself to do homework 4, let alone 5, please don't feel, and now I've changed the dates or readjusted. Please do not feel like, oh, are you kidding me? I mean, I think one person in the chat is like joking. I get it's a joke. But again, just want to read first. Do not think, are you kidding? That was like totally a waste. No, it wasn't. You did yourself and me a big favor by whatever big attempt you made first. Really. I can't emphasize enough. Now, and I'll be more specific now because one person in the chat is saying, hold on, I don't, like, I see you gave me points, but like you didn't give me feedback yet of what to correct. That's true because I haven't even talked about it in the class yet. So generally what happens is as we all get piled up, I mean, first I'm going to say a lot of things in class that hopefully will address like a lot of your things. But then, and for a lot of you, you'll see right away what you need to do just from class. But yes, I will, and my personal feedback will get more spotty and more like random as things get more crunchy through the semester. But so to hang tight, basically, if you're one of the people that already did it early, if you're itching, just send me another thing, another comment in the portal. Say, I'm itching for feedback as quickly as you can get it, or whatever, or just repost it again. Say, just a reminder. I think you were promising me feedback. Like I will, but I may. But unless you do that, I may wait on many of you until I say a bunch of stuff about it in class, because for many of you, like you, anyway. Hopefully that's clear. But just send me a reminder, and I will. I'll put you to the top of the pile, like if you're itching for it. We'll move on, but you will see by next semester. And there's even a sheet about this in tools that we don't talk about a lot, but there's like a supplementary, like optional sheet for help called Knowing What to Do When You Don't Know What to Do. It's in tools. It's not required. It's just like whatever, a sheet for reference. What we're trying to learn ultimately in physics is exactly that. We're actually trying to learn what to do when we don't know what to do. We're really, which like, i.e., original science research, like figuring out things for the first time, which means literally not just how to know stuff, but how to get smarter, right? So that is a very hard thing to learn and to teach. And part of where it comes from is getting used to doing things like assignments before someone tells you how to do them. And so, and it means getting used to actually groping around and making a lot of mistakes and being okay with incompleteness and mistakes the first time you go around something. So I'm just a long way of saying again, I didn't mean for it to be this extreme, for you to be like weeks ahead of me. That was a mistake. That's why I'm readjusting the dates. But for any of you who tried or remembered things from high school or went on the web, like you really did get a leg up on practicing like how to know what to do when you don't know what to do. So, and I noticed that you did. That's why I gave those points. It's just as an acknowledgement, like I know who you are. So don't think it was wasted. It wasn't. But all right, I'm going to move on. I'm wasting. Okay, sue you. My God. Well, feel free to sue. I mean, we could talk about that too. I mean, yeah, no, okay. All right, I'll move on. All right, it is funny. Okay, I'm moving on. All right, so I'm moving on to, I mean, just let's not even talk about what material assets I even have for you. I mean, you'll get a calculator. I mean, what can I tell you? But okay, yes, all right. So I'm going to do a quick in order, but it is funny. It is funny. I'm appreciating it. I'm going to do a quick screen share just to make clear where we are to everybody, especially if you're like watching this later on a video or something. I'm showing you what I want to talk about now, but you can keep the good. Huh? You guys are funny. All right. I'm trying to work because I know people just want to get on with it, but there's funny things, at least in my chat, that are happening. Okay. I appreciate it. I do appreciate the upbeat attitude. Okay. This is This is what we're about to do. This problem right in the middle, right? Hill figure. There's a hill in East Smurf Village. On the hill is a trail. No one knows how long the trail is. Definitely an interesting feature of the problem, for sure. So we're not given a distance, but we know we go up that distance at a certain given, known average speed. Then at the top, Papa Smurf, the driver, takes a negligible amount of time to turn around. Oh yeah, and it explains what negligible means. So quick sidebar. I don't want to get into a rabbit hole, but when physicists say negligible, that is our way of saying, yeah, you can ignore the number, but we're saying in a way that is meant to remind you this is science, not math. Like we're saying, oh, you could imagine that this is an actual experiment that could actually happen in real life. We're not saying I mean, not with Smurfs, obviously, but like okay, I'm gonna grab. When we say negligible, we mean exactly what those parentheses mean. We mean that the kind of clock you would use to measure how much time the driver takes to go up the hill, whatever clock that is, say it goes to hours and minutes and seconds, right? But not to milliseconds. Then by the time you try to use that same clock to measure the amount of time that it takes for the car to turn around, it won't register on that clock. It'll be between the cracks, like it'll be too low, milliseconds or whatever. And similarly, we mean, then you might say, well, why don't we just get a clock that has milliseconds? Like, what is this? But then we're saying if you have a clock that's so precise that it goes to milliseconds, then it's not at a large enough scale to handle, like it'll be pegged, it'll be broken, it'll go to infinity if you try to use that same clock to measure how much time the driver takes to go up the hill. We're literally saying that there's two scales of measurement in the same experiment, and they cannot both be captured on the same tool. So that when we say we're going to have to ignore, like one of them is too small to measure, we're like literally saying that. We're not saying it doesn't exist. We're not saying this is just in our imagination. We're saying there is a quantity in the world, but it is too small to distinguish from other quantities by the same tool that we use to get the quantities that we need that are relevant for this experiment. So this is an experimental standard. I mean, I'm going to move on, but that is my way. But I'm going to say this again in different ways, like in next semester, over the semester, next semester. When we say in physics, you're ignoring that quantity, it's because we are respecting the real world and being in the real world, not because we're ignoring it. We're saying we're so real, we only believe numbers that we can measure. That's how real we are. We don't make up numbers. We only measure them. So if you can't measure it, it's not a number. That's what we're saying. Okay. Anyway, so so he turns around so fast that we can't measure it. Okay. Then he comes down at 60 miles per hour. Okay. And then, but the same distance, right? And we want to know what's the average speed for this whole trip. So we just want to know average speed, right? An average speed, we just want to know average speed for the whole round trip. It is assumed that the up trip is the same distance as the down distance, but we don't know what that distance is. That's okay. And we assume that this is a reasonable problem, like that there is an answer to it. Okay, so I'm switching the screen share. Oh, and there is something else in the chat. Sorry, hold on. Oh, oh. Oh, yeah, yeah, yeah. So wait, so this is not a joke. So in the chat, sorry, so someone's asking in the chat, are we allowed to do homework ahead of what I'm teaching after today? You're always allowed. Yeah, and you always should. Honestly, you're always allowed. And especially if it's a first draft, so if you hand it in on time, you can always change it later. So absolutely, especially if you do it according to the 5-step method or whatever, you're always allowed. Two quick things about that though. One, I don't mean for you to be expected to do homeworks like two classes ahead of where we are or two assignments of where we are. I mean, even if they happen to be posted, I wouldn't expect, and I won't necessarily help if you go like two assignments ahead or something. I'm not prepared to give feedback or answer questions yet at that moment, unless we like literally make an office hours appointment or a Zoom or something. I mean, to be clear to everybody, okay, you could go try as hard as you want, but I'm going to like stick to where we are. That's number one. And certainly you're not required to go any more than like one step ahead of where we are. But then the other thing too is to everybody, the more you're ahead you're going, don't only write down and do things that you understand what you're doing. You can find out understanding any way you want. Like if you could figure things out from the web or from your old high school notes or from older friends or MS, do it. But don't write things down that you get from the web or from other people that you don't understand just to get ahead. Like that would be a mistake. I hope that's clear. And whenever I write, if I ever write on any homework or any exam, if I write www, that means what is this? Why is it true? Where is it from? And that is a polite way of me saying, I think this is sus. If I say www, I'm saying like you're writing something down that I don't really feel like you get. It might be true, but I don't really think that you've worked this through. And you don't want a lot of those, like especially on an exam. Okay, so hopefully that answered that question. Maybe, hopefully, I'm going to switch to screen. Oh, it did it. Okay. Yeah. Oh, it was good. Okay, great, awesome. Thank you. I've never been called concise before. Okay, awesome. All right, so I'm going to switch the screen. I'm going to go. I'm going to start taking notes on like doing this problem. I'm going to try. Hold on. Give me a second. I. Okay. 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 So I'm going to start the problem. What does it say on the front? Like, why does it say this? The second equation, you see, hopefully it's the one equation we have for the class so far. Average velocity is defined to be displacement over time. Again, for this problem, really technically, we're sort of dealing with average speed and distance, but that's like sort of the scalar version, the magnitude version of this idea, right? Um, it's like the English version of this equation. But above it, just to be clear, like the whole thrust of this problem, what it says above is triple equal signs do not, by definition, equal double equal signs. In other words, I'm reminding you, and I think stop me if I've not said this before, but I want to say very explicitly, oh yeah, I have said it. Of course I've said it. Okay. A triple equal sign means equal by definition. A double equal sign, a double equal sign means equal by discovery or condition or inference. So the big thrust of this problem is what average speed is defined to be is distance over time. That's what's always true about average speed. Anything else that you might think might sometimes be true about average speed is just that, something that sometimes might be true about average speed, but we have not established as a universal meaning of average speed yet. So, okay, so I didn't mean to do all this. Sorry. I didn't really mean to do it in yellow, but I did. Okay. So, okay, right. This is my diagram. Notice I made a diagram, even though the problem didn't, all the more even though I wasn't given a diagram, all the more reason that I have to give a diagram, right? So there's my diagram. It's all the facts that are known. Okay. Then step two, what's the question? The question is, what is the average speed for the entire round trip. Now, average velocity, we're defining to be V with a bar over it. So just to be as clear as I could possibly be, I'm putting like double absolute value symbols around to say, to make it clear that what I'm really being asked in this problem is not so much average velocity. I'm being asked average speed, right? Because actually the average velocity for the whole thing would be zero, right? Because it's a round trip. But I'm being asked the average speed. So technically, when you put double absolute value symbols around a vector quantity, it means just only the magnitude, only the raw amount of that vector. Okay, so that's step two. I mean, you can stop me. I'm trying to, please feel free to stop me if you want, but but I'm not stopping myself anymore. Okay, so step three. I'm just looking if there's anything in the chat. Okay, step three. Now, GDP. The only GDP I know for this problem is this. And you could write it in English, like that's like the equation. Average velocity is defined to be displacement over time. And you could say, right, this is my step three. Now, it's not new information to anybody in the class. But what I want to emphasize before, and I will move on to step four, what I want to emphasize is that's the only possible thing I really can say for step three. Um, and that means whatever I do in step four has to rely on that and nothing else. So in other words, when I go now to then there's many I did mention, and I will stand by, there's many different ways to do this problem. But one way not to do this problem, so I'm not going to write down, one way not to do this problem is to take 40 and 60 and average them together and get 50. Yeah, and I'm not trying to shame anybody or critique, but I mean, some people did that. And frankly, in past years, like 10 years ago, that's what everybody would have done on this problem. I like it is the common expected thing. It's not shameful, but it is wrong to take 40 and 60 and average them together and get 50. And what I really want to emphasize now is it's not just, I mean, it's wrong for a variety of reasons that I hopefully will bring out in the physics, but it's also wrong because that's using like a formula or an equation that no one ever established to be true here. Like that's if you add together 40 and 60 and divide by 2, that may sometimes be a proper thing to do in some context in a math class, but it's not at all what we just said in step three. So it's coming out of left field. So part of the step method is to like force us to be logical. Now I'm just looking at the chat. Okay. So I'm not, in other words, what I'm just trying to say is ultimately, I think average speed is called average speed for a reason. But no one ever said that average speed is the average of two speeds. The reason isn't the reason that it's called average speed. Okay, I think a lot of people stop me if you don't get that. Like, I have no reason to just average numbers yet. No one ever said I could do that. But now let me go a step further. There's something very interesting that many of you did, and honestly, I mean more than two people did something that I don't think I've ever seen before. I mean, in my life I've seen it, but not like on this homework assignment in this class. So a couple of people did something where they were like 40 times 60 divided by 40 plus 6, or no, sorry, divided by I don't even remember now. It was something like 40 times 60 divided by 2 times 40 plus 60 or something. Something that did work out to a right answer. So again, I am not shaming anybody or anything, But I'm being dead serious when I say if you are one of the people that did that, I mean, yes, I'm not giving it full credit because I don't know where it came from. I'd like on the homework, I'd like to see, or if it were an exam, I need to see more of an explanation from where that came from, especially if it wasn't in step three, or put another way, wherever that is, whatever that is, I would need it to be explained in step three before you use it in step four. But I will say it's interesting enough, and there's obviously something very legitimate about it. If anybody has the courage or the inclination to talk about it in direct chat or public chat right now, I'm all ears. Like, I'm not trying to slam it down. I'd actually like to hear more about where that came from and what you were thinking. So, or even just if you just want to in the direct chat, I mean, I'll even give points for, I mean, you will get points for this. Even if in the direct chat, you just have the honesty to say, yeah, I was one of those people that did that. I got it from the web, and honestly, I don't know what that is, but I did it. Like, I won't punish you. I would just like, but I would like to know what people's headspace was on that. Or I'd also like to know that I'm not crazy for thinking that I saw that on a number of homeworks. But so please put in the direct chat, if you put something like 40 times 60 divided by 40 plus 60 times 2 or something like that. It was 40 times 60? I'll tell you. It was 2. No, that's what it is. It was 2 times 40 times 60 divided by 40 plus 60. I'm pretty sure that's what it. Yeah, that would make sense. Yeah, which works. Like, it does work. I'm not saying, and it's in a way, it's brilliant if you have a brilliant understanding of what the brilliance is. Anyway, so someone, in the direct. Yes, that is what I'm talking about. Okay, and by the way, like, triple guts to Colin. I mean, triple kudos to Colin for having the guts to put this in the chat and to go public on this. Okay, and definitely. So, for example, definitely submit in the portal that says for right or for wrong for points. Like, screenshot this, and if you just, not that I'm saying it's wrong, but you can also submit in the portal that says be wrong, be really wrong. It's not wrong, but just so you can get more points for it. Because I do think it's wrong to just put this down as a step 4 in the homework. Like, it has to be explained, is what I'm saying to everybody. But yes, that's it. What Colin put there. I'm wondering, Colin, and you don't have to, you're already getting like, but Colin, does it make sense? Like, where did you get that? Or what's the reasoning behind that?
I forget exactly where I got it, but it was another derivation of the round trip average velocity.
Oh,
Um, yeah, it was. I forget exactly. It might have been in another physics book or
oh,
one of the
like,
physics books. It
oh,
was
that's
for round trip velocity.
for round trip. Okay, that's great. No, totally
It was
helpful.
using like two times the distance. I forget exactly the origin, like, but that's how it was derived, and that's how it ended up. Was two times v1 times v2 divided by v1 plus v2.
Okay. That's totally awesome. Oh, and you just used your voice and you're using video. So I hope you do submit for like tons of points for that series. And I'm seriously, that's super helpful for everybody, for me, and I hope for everybody. And now I see. Okay, so to everybody, and this is a perfect example, really, like, this is like education. Okay, like, I am saying he's right. I'm not saying that's wrong. Like, I know the numbers totally work. Um, what I am saying to everybody is that is an example of something like, say this were an exam. Yeah, you would have to explain it more. Like, it has to come from somewhere. It has to be, spoken through, written through. Um, by the time we get to an exam or whatever, to get all the points for it. Um, but one of the key things he just said that I didn't even get when I saw his homework or other people's homeworks, what he's saying is that specifically is an equation that works for round trips, which, now that he says that, I can see it in my mind's eye why that is. I mean, in fact, he even just threw out like half the explanation. He, being Colin, just said, like, right, because if it's a round trip, whatever the distance is, you go there and then you come back. So it's the same distance that you go there and you come back. So there's like a 2D or a 2x or whatever that would be in the numerator. And then, I mean, I could see this in my mind, and we'll all see this in a minute when I do it my way. Then time in the denominator would be distance over speed time would be distances over speed. So the distances over the speeds would have x's in them as well. So the x's will cancel out and you'll have this 2 in the numerator. Like it, I'm saying, that, oh, wow, that's really interesting. And honestly, again, honestly, people, like I've been doing this for over 30 years, and for whatever reason, I've never seen anybody do it that way, not explicitly. So it is interesting. It's like educational to all of us. It's clever, it's cool, it works, but it clearly requires like an explanation. It's not like some standard. Basically, what I'm really saying, and I'll move on for those of you who are like losing your minds. What I'm saying is that is not a triple equal sign. That's a double equal sign. It's something that works out for a particular circumstance, but it's not like a universal principle. And both are real. We have a place for both in physics, but it's really, as things get harder, it's really important to distinguish one from the other. So one thing to think, the rule of thumb for those of you I'm losing, is when you do step 3, generally think in terms of triple equal signs. Think in terms of things that are just like true, like just true across the board. But, and then in step 4, you're applying these universal truths to the circumstance. So of the problem. So at the end of the day, I mean, everything in physics looks like equations by the end. So everybody thinks physics has all these equations to memorize. What I'm trying to teach is that everything at the end of a physics problem looks like an equation. Because everything at the end of a physics problem, we're saying this equals that. The speed of this situation is that number or whatever. And as we get more sophisticated, we're going to be saying at the end of any physics problem, this speed in this kind of situation is always a function of this kind of distance divided by that kind of blah, blah time, whatever. So everything looks like an equation at the end of any physics situation. So if we then thought we were supposed to memorize all of those equations that we get at the end of problems, especially for studying for tests, no wonder then physics really would be crazy intimidating. I mean, it is intimidating, but it would be crazy hard to navigate. And the secret of physics is that's not really the way it is. We have a few equations that are triple equal signs, and then we get used to applying them to each different situation and generating our own new double equal signs for each new situation. And then we forget about it and move on to the next situation. I mean, unless it's like really applicable, right? So, okay, I'll stop talking, but I love this. And I love that Colin had the sort of the honesty and the intelligence to like say, well, that's what this is. That's what this thing is. It's not random. It's like a complete thing that works for round trips. But right, okay, it works for round trip. But I'm not going to ask any of the rest of you to memorize that for an exam or something. Like, okay, I'll move on. Hopefully it's clear. Okay, okay. But all right, so what did I do? Like, where did that come from? How did he get that? This is what I think. I think, okay, okay. So what I'm saying is the way I'm just looking at chat. I'm saying what I know, all I know, and this is going to ultimately show Colin's point again. I know that average speed is total distance over total time. That's what I know. I mean, it's what it means, right? So the total distance, so if I let X stand for a one-way leg, then the total distance is 2 of those, right? I mean, again, that's like a big takeaway of what Colin's saying. So if you call X like the up trip, then 2X is the total distance. Okay. So the average speed will be 2X over the total time. Now, the total time is not like 2T or something. First of all, I've never said that T was the time up or something. But second of all, the key point is the time up is not the same as the time down, right? It's the same distance both ways, but the car went slower on the way up than it did on the way down. So the times are not the same. So what is the total time? Well, like if I knew that, if I knew the total time, I would almost be in business, almost, right? The Or let me put it another way. What's hard about this problem is there's a lot that I don't know. I don't know the distance. I don't know the time. The only equation I know is average speed equals distance over time. So it seems like, you know, this is why people unconsciously make up equations that aren't necessarily true. Like they'll just make up 40 plus 60 divided by 2 because the one thing that we know to be true feels like it's missing a lot of information. But what we need to do in physics is whatever is unknown, that's what we have to confront directly. We have to assume if the problem is a coherent problem, that what we don't know can be unpacked more than we initially realize. In other words, the total time definitely is the time up plus the time down, right? I mean, just like the total distance is the distance up plus the distance down. Only the time up and the time down are not the same thing. What are they? Well, again, remember the one thing I know is this, right? I'm writing it like this. And to cut to the chase, also, like wherever I start, I'm always assuming is a position that I can call zero. Right. So again, so you could write these out in English, or you could write them as equations. I'm trying to think of them as equations. So in other words, if 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 average speed is distance over time, then what time is for any situation, time is distance over speed. Yes. Now let me pause on that for 1 second. Well, maybe that may be too many steps for some. Sorry, I'm saying V bar equals X over T. Like that I know. So I can multiply both sides by T. I mean, I'm not going to do this every time, right? But I can multiply both sides by T, and then I can divide both sides by V bar, right? So now I can say time is distance over speed, right? Now that is always true. I mean, if average speed is always distance over time, then time is always distance over average speed. Again, note, I don't want you to memorize like there's three equations packed into one here if you get algebra, but that's why you took a course in algebra. The point isn't to memorize all these different permutations. The point is to know that they're always there and available every time we have a new situation. So I'm saying time is definitely distance over speed. Stop. I will watch the chat. Stop me if you don't like that, or put in direct chat if you don't like it. There's no shame, but I'm going to go on if you don't. So therefore, time up, right? Time up would be distance up over average speed or average velocity up, right? And time down would be distance down over average speed down. This still looks like all a mess. It looks like I'm making life worse, not better. That's how physics goes. It feels that way until it doesn't. It is literally like if you're doing construction or whatever, when you're cleaning your room, you got to take things out of the closet first and put them everywhere. The room is going to get messier before it ultimately gets cleaner. Stupid analogy, but you know what I'm saying. Because now I can start saying, well, wait a second. I know a lot of these things. Like X up is just what we called X before. As far as X's are concerned, I don't have to distinguish between up and down. And V up was a given. It's a number. It's 40, right? And X, so all this is okay, and X down is that same X, and the speed down is 60. What am I doing here? This is all a big sidebar, if you like, in a way. This is all a big analysis of what the total time for the trip is, right? But now I'm almost home then. right? Because the whole purpose of all this is all part of step 4. It's a little bit long. Step 4s tend to be long. It's all work, it's all algebra or whatever, but notice it's not making up any new ideas. It's literally just, okay, you got my point. So thus, I'm saying, thus, a- average speed, average speed equals 2x over 40 plus x over 60. You see what's happening? Now I can, and that's what I'm looking for, average speed. So I'm almost there. Now, look, I had a whole bunch of unknown things, it seemed like, but really I didn't. The only thing that was unknown the entire time, or the only thing that was explicitly left out of the problem, was the distance. Because the distance was left out, it made it seem like all these other things that depended on the distance were unknown. But the whole key is they all depend on the distance in a direct way. So as long as so they're all, it's really only one thing that I don't know. And now what I see, and again, this is now sort of the Colin point. Now I see, wait a minute, I could factor out an x from the numerator and factor out an x from the denominator, and they cancel, right? Again, tell me in the direct chat if you don't like this, but I'm saying I believe it's totally legal to do this. And by the way, it would not be legal if there weren't an x everywhere. Like if there wasn't an x over that 60, I couldn't, but there was over the 40, I couldn't do this. But I'm in my mind, I'm factoring out the x from the denominators. So I'm looking in the chat. Oh, can I repeat that again? Thank you. Someone just said, by the way, the person who said, can you repeat that again? Please go back points. Because yeah, I figured somebody I need. Okay, but now my only problem is it was 3 minutes ago. So what am I repeating again? Or what am I repeating? I really do want to repeat whatever you needed me to repeat, but what was it? I'm repeating, uh, could you repeat what you want me to repeat, direct chat person? So the breakdown of the equation. Like, okay, the breakdown of the equation. Thank you. Like this thing right here. Like okay, so what tell me if this is what, I don't remember exactly what I said. Okay. So that, okay, so this whole thing, I guess this isn't like a repeat, but an explanation. I'm saying all this is total time. Like literally this craziness here. Okay, cool. This craziness, x over 40 plus x over 60, is a long way of saying literally the total amount of time that that the car spent doing the whole round trip. Because x over 40, that fraction x over 40 literally is, and if we say more specifically, like x miles over 40 miles per hour, that x miles over 40 miles per hour is literally how much time the car took to go up the hill. It went x amount of miles, but it did it at a rate of 40 miles per hour. And so if you take just like if I'm saying average speed equals distance divided by time, but you might remember this from seventh grade or something. You might think in your mind like distance equals rate times time, right? Like that is what I'm saying. They are, as long as you understand that rate means rate of average speed or average rate of speed, right? If you think in your mind distance equals rate times time, I'm saying, yeah, therefore, like I'm saying, that's this right here. I'm saying, therefore, in your mind, divide both sides by rate. If distance equals rate times time, then time equals distance over rate. You never cared before. It never sort of came up before, but it's like true. So I'm saying the time up the hill is X miles divided by 40 miles per hour, and the time down the hill is X miles divided by 60 miles per hour. And honestly, I hope this is helping other people too. Tell me that, okay, cool. Great. Okay, awesome. Right. So then the total time is the time up plus the time down. Okay, cool. Thank you. Thank you. And you should definitely submit for points for that. And I'm sure that didn't just help you, really. And if nothing else, it might have given other people a chance to think about whatever else they wanted to think about. So yeah, okay. So all of that is the big denominator of the fraction that we think we don't have. Like that's time totally that goes under total distance, which is 2x, right? So now I'm saying you can factor out those x's and cancel out those x's. So now at the end of the day, and this is honestly what happens in physics. Like things blow up and then they shrink down. Like this is what happens in physics. And it works. It always by the end seems like, oh God, why didn't I? Well, no, it always by the end seems like, oh, duh. But it's not a duh. We had to go through all this to do it. Right. But what we had to have was sort of the courage to look at exactly the pieces that we thought we didn't know and squeeze them until we know them. That's the trick, is not to just pivot and go, well, since I don't know, okay, I think average speed equals distance over time, but since I don't know the distance over time, let me make up something else. Like that's what we don't want to do. But so if we cancel out the x's, now what we're saying is 2 over 1 over 40 plus 1 over 60. And first of all, notice, honestly, that's essentially what Colin said. Like, and I'm not to just like make this whole class about Colin, but I mean, right, if you look at his, I think if you look in the chat, his chat is, and there's more going on chat. I'll check in a second. Thank you. But I'm looking at what he was the one that put in the chat, I believe. Yeah. All right. Well, okay. Maybe I'm still one step ahead in my mind. I'm telling you, you may or may not see it, but the logic of that equation that he put in is essentially captured right here in this step that I just did. Again, am I saying you need to do a Collins way? No, that's not what I'm saying. I am saying I'm saying that you can do a Collins way as long as if you explain it, you'll see it's the same logic as what you get my point. But what's really amazing, we're almost done. We don't have an answer yet, but we almost have the same answer he would arrive at. What we do have is an expression that has all given known constants in it. Like there's no more unknowns anymore because the x is canceled out, which, okay. So now, oh, here comes, okay, here's really the Colin part. I'm sorry. Like, how can I do this? Well, it's like a fraction within a fraction. Well, we go step by step. Like how, I mean, you could just do it on your calculator. That is, you certainly could just do it on your calculator. But also, like, how do you add fractions with different denominators? You get the lowest common denominator or the greatest common, whatever you, right? In other words, this is what I would do to add this together without a calculator so I can get a feel for it. I would say, look, I would think of a number that 40 and 60 both go into. I would think of so I guess that's the greatest common factor. I would think of a number, the lowest possible number into which both 40 and 60 evenly divide, right? And the number that I'm thinking is 120. You could also do 240, or if that's too much of a leap, you could just literally multiply together 40 and 60 and go 2,400. Again, actually, that then would bring you to the Colin thing. But so I'm in other words, I'm gonna go like this. I'm gonna go like this. Okay, hopefully that okay. And I'm going to the next page. I'll just write it again. You could turn me, and I will look in the chat in a second. So now what do I have? I have 2 over 5 120ths, right? And so we're almost there now. It's like, okay, what do you, it's a number, it's a fraction divided by a fraction, or it's a number divided by a fraction. What do you do when you divide by fractions? You multiply by the reciprocal. In other words, this is 2 times 120 over 5, which is to say that it is 240 over 5, right? That's what, if nothing else, physics just like shows you that all these things that you spend your life learning in math actually mean something. It's like actually useful for something in the end. So then I would say for step 5, okay, for step 5, how did I do this before? For step 5, I think this is my answer, or I'll put it on the next page to be clear. I'll turn back the page in a second if that's what anybody wants. I'm saying if you're in equations, like because this is average speed, I'm fine with writing it in English or like in equation notation. If it were average velocity, if that's what the question we're asking, I would like pretty much stick strictly to equations. But in other words, you could write it like this. I'm saying a perfectly legitimate answer would be this. Okay. Oh, four. But this is for the round trip. Now, this is the answer. I still have more, okay, like, so we're done. That's the answer, but I still have a couple things to say about it, but there was something in the chat. Wait. Oh, okay, something in the chat and keep it coming. All right, so one person in the chat is saying that it's genuinely helping me understand the problem. Okay, so thank you. I appreciate you telling me that because I was very confused. Fair enough. You're not, and a lot of people, and anyway, you're not alone if you were confused. But then the person said, I didn't know how to factor or consider the time in the equation since it was called negligible. Just to be clear about one thing. Okay, I sort of thought I was over rabbit holing this before, but maybe I was under rabbit. The time that was called negligible was the turnaround time. Okay, so this is another thing to be aware of in physics or to be careful about in physics. There's always a balancing act in writing these physics problems. English is not literally the perfect language for physics. Math is much more a direct, precise language of physics. Math is not physics. Math is the language of physics, right? But obviously, some of us are more comfortable with math than others. So that's like, there's disadvantages and advantages of the math, but there's also disadvantages and advantages of the English. What often happens is if we don't say enough about a problem in English, then people are confused in one way. But then we start saying a lot, particularly me, and then it starts confusing people in another way. It's all that's part of all this is getting used to the language and knowing like what things to pay attention to when. So we had to say in the writing of this problem, we have to say the turnaround time is negligible. What we're trying to say is it goes up and then it comes down. And that's all you have to calculate in the problem is stuff that happens on the way up and stuff that happens on the way down. Like I want to be like maybe it's clear now. I don't want to beat a dead horse, but we're not saying that the time up is negligible. Definitely not. Like the time up is very significant and the time down is very significant. In fact, and like that's what we were spending all this time dealing with. We don't know it, but it is large and meaningful. What we're saying is not meaningful. What we're saying that you can neglect is the amount of time it would take the car to turn around. Okay. And we have to say that just because we want to keep reinforcing, like you should be picturing an actual thing occurring here. You shouldn't just be like it isn't pure math. It's a physical situation in time and space that we want you to be able to picture as something that actually could be an experiment, right? But in that experiment, if you sent something up and then it came down, and this will be literally lab 5, like lab number 5 in this class, you will send something up a hill and it'll come back down. And you'll have to do all these calculations and friction will be involved in all this stuff, right? It's like real. But you're going to see when you do it in the lab, like all these things matter, but it's not going to take any measurable amount of time at the top of its round trip trajectory. It's not going to take any amount of time that affects any of the rest of your calculations. That's what we're trying to say. So I mean, hopefully that, so I don't know if that's helpful or worse, but the time up and down definitely matter. But yes, you don't know them. So this is the thing of physics. And I will go on in a second. I'll look at the chat anyway. Like a lot of times in physics, you don't know information. And so the trick is like, what do you do with that information? And really the ultimate answer is this is where math like such as algebra, trigonometry, and calculus come in. We make up placeholder names for those numbers until we know them. Like we call them T or we call them X or something, meaning they matter. We're doing stuff with them. We just don't literally know what they are yet. I don't know. So I'm going to say more, but hopefully, I don't know if that addresses it or not. But oh, okay, okay, it's helping. Okay, okay, spoilers. Okay, wait. So I'm just looking at the chat. Spoilers. Okay, okay. I think that covers the chat. Now, I know we have other problems to do. We have 15 minutes, but there's many other ways to do this problem. I'm never saying you can't do a problem your own way if it works. But like even that equation that I had never sort of seen before, but everything you do has to be explained. And what does explain mean? It means you have to do for me what I'm trying to do for you, which means get me to the point where as long as I agree on certain fundamental things that seem self-evident, like you do, like as long as we agree that average speed is means distance over time, then can we go step by step logically to see how a certain thing is true in this situation. It just means not. And again, people don't realize that that's true of physics because we're biology and chemistry are a little bit different. Certainly biology. Like we don't, and I'm saying this with respect, but like we don't try to just pull knowledge out. Like we're trying to build knowledge, not rely on it, if that makes sense. So, so, so you might not have done it this way. This might seem abstract to you. I don't know what about this you would literally do exactly like you might not ever see this exact problem again, but can I point out one thing about this? Right? I mean, if you really think about this, if you're clear-headed, I think you'll agree that what is tricky about this problem is that we're not given the distance. That's such a tricky thing that the good thing to do is to be like, wait, I don't have the distance. That is a challenge. I need to do something about that and maybe even get yourself confused and maybe even do the wrong thing. What's not right to do about that is to just like be like, well, then therefore, whatever, then I have to do a different method. Like I thought it was average speed equals distance over time, but since I don't know the distance, that can't be the right way. I got to do it a different way. No, no, that is the right way. We have to think about the fact we don't know the distance. Well, here's something. If we don't know, if we're going to confront directly the challenge of this problem, which is that we weren't given the distance, how about think about this for a second? If we don't know the distance, but it's an actual solvable problem, if we don't know, here is a little weird takeaway about this problem in physics in general. Assuming the problem is meaningful, like assuming we got this was like an experiment or a discovery, like assuming this problem is not a trick. Well, if we were asked to get an answer, but we weren't given any distance at all, if you really think about it, that means that the answer is independent of distance. It actually means there's like a physics discovery in here or built into here where somehow the answer, like I just got that the answer is 48 and I got the answer is 48. It's not that I figured out the distance and then got 48. It's that I worked around the distance and got 48. In fact, specifically, the key moment was I like made a placeholder for the distance called X, which is what you do. Eh, But whatever is going to happen, that's what you do. But then this cool thing happened where the X is canceled out. At the moment the X is canceled out, what that demonstrates right there is, oh, that's why we weren't given a distance, because apparently it doesn't matter. And why doesn't it matter? Well, average, how could it not matter? Average speed is distance over time. Like obviously, the farther you're going in a given amount of time, the faster you're going, right? But the fact that it's up, the math means something. The fact that the distance came into the numerator and the denominator, which again really is the whole column thing, like what that means is, well, yeah, the farther the hill, the bigger the hill is, then the more that distance is going to affect how, like if you're going up the hill in a certain amount of time, the bigger the hill is, you must be going faster, right? But the bigger that hill is, that also means the more time you must take to go up the hill and down the hill. That's why the distance is factoring into the numerator and the denominator in the same way. Because so to say it cancels out is to say, oh, whatever impact of the distance I thought there was, that like bigger distance would mean I must be going faster, it actually cuts both ways. Bigger distance also means I'm taking more time. So I'm not going, so it cancels out. So what we could have done actually is we could have picked any distance at all. Like when I picked that lowest common denominator or that greatest common factor, 240, in a way, I was doing raw math, but if you want to think of it as physics, like you could hypothesize, you could say, hypothesize a hill of of um of 240. Do I want to say 200? Yeah, of 200, like imagine that the hill or 120 of 120 miles up and therefore 120 miles down, right? I could just say that because apparently, and now the math will be real easy. Then I would just say, oh, the average speed is 2 times 120 over over 120 over 40 plus 120 over 60, right? Which is 2 times 120 over 3 plus 2, which is 240. And this, again, if you look at the numbers, what I'm doing here, it really, that's the Colin formula, like just reducing this to a formula. Right. And then you can say, wait, and you'll get the right answer. Right. And then you can say, well, that's nonsense. You just made up 120. Why is that fair? How is that science? It's science because if I dare you, if you try to make up a different number, if you try 240, then you'll have 2 times 240 in the numerator and 240 over 4. You'll have 2 times 240 in the numerator and you'll have over 6 plus 4 in the denominator. It'll work out the same. Right? That's the point. The distance doesn't matter. So is that a legitimate way to do the problem as a physicist, to just try a distance, see what answer you get, and then try a couple of others to verify that no matter what distance you tried, you're always getting 48? Yes, that would be like an experimental way to do it. It's science. So the answer is, so lastly, I know we only have 7 minutes now. So I say that the answer is 48. And what this 48 really means, I think I said this quickly at the end of class last time. So you to bring the full circle now. Now again, this is what always happens in physics. I know a lot of you, I could tell from the direct chat, at least some of you are like, oh, I get it now. It makes sense. Good. Of good. We're getting our money's worth, right? Some of you, what I hope you're not doing is what I always used to do in college and graduate school. I hope you're not going, oh, it makes sense now. I'm such an idiot for not seeing that before. Don't do that because you're not. You're not. We're here for a reason. It's a process. Also, don't go, oh, I get it now. He's such a jerk. Why didn't he tell us this before? Well, I mean, maybe I am a jerk, but that's not the point either. Like, this is what it means to unpack physics. It always seems obvious on the other side. It's not obvious until it is, which is to say, really, it's not obvious. It's just correct. It's not obvious, but it is correct. And it does make sense once you see it, I hope, I think, right? But then if you're thinking to yourself, but wait. And like, but now if I go to do this at home on my own, is it going to make this much sense when I do the next new problem on my own? Like, no, it won't yet. It comes with time. You get better and better at it. Each new problem is a new problem. This doesn't solve all the rest of your problems for life, right? But it will help you in future problems. Also, if I do take the 5 minutes to also address what some of you did, like this all shows why the right answer is the right answer. It doesn't really show you why the wrong answer isn't the right answer, right? And that's what you need too. Like, don't forget that some of you might be thinking, okay, this makes sense, but like what I did was 40 plus 60 divided by 2, and it seemed reasonable at the time. Like, why is that not okay? Like, well, I thought average speed means average the speeds. Why is it not okay to average 40 and 60 and get an average of 50? Like, what? Good question. Because there is a reason for this, for it being called average. It is, that's the next class. Okay, we have 4 minutes. Excuse me. Like, how is this an average? Why is 48 an average? It's an average because average means the one number that best represents the whole. That's what it means, right? It means if you were to act like numbers were never changing, what would be the one number you would pick if you, even though numbers really are changing, right? Like very quick, and I am watching the clock, but like when we say you have an average of 90 in the class, we're not saying you always got 90s on all exams. We're saying you got a bunch of different scores on a bunch of different exams, but if we were to pick one number, that would be the equivalent of like if you were to get one number on all the exams, what would it be? That's what it means to say you have a 90, right? So sometimes that's triple equal sign. The double equal sign is sometimes that means you like add two things together and divide by two. But it means that when you only have two things, right? Like literally, and I think I said this last time, but if you got a 40 and a 40, and God forbid, quark forbid, if you got a 40 and a 40 and a 40 on exams, if you got three 40s and then you got two 60s, we wouldn't take 40 and 60 and add them together and divide by two, right? Your average wouldn't be a 50. It would be closer to 40 because you got more 40s than you got 60s. And if you got literally three 40s and two 60s, we would say 40 plus 40 plus 40 plus 60 plus 60 divided by 5, right? And or in other words, we would say 3 times 40 plus 2 times 60 divided by 5. We would do a weighted average, if you like. There would be more weight being, and that's exactly what's happening here, right? This is a weighted average. It is an average, but it's weighted because this car spent more time going 40 miles an hour than it did going 60 miles an hour. So the average is closer to 40 than it is to 60. Why did it spend more time going 40? Because 40 is a slower speed. And so since it was going the same distance, both trips, it spent more time doing that distance at a slower speed. How much more time? 3-to-2 ratio. Why am I saying 3-to-2? Because 60 is to 40 as 3 is to 2. Honestly, like and that's literally what's happening in this algebra. And literally what the equation that Colin brought to bear is like ultimately capturing. Like, I know hopefully you could see that. I'm saying it really is an average, but it's the meaning of average. It's not just one particular procedure of average that works in one particular case of only having two items. I hope that, I'm just saying, right, because it's a weighted average. 3 is to 2 as 60 is to 40. So I'll leave it at that. I think, great. So someone said, great. So one person in the chat said this makes a lot more sense. That's good enough. I hope it does. And again, hopefully this is meant, and we'll go faster and faster, but I'm trying to lay down like how physics thinking works in general. I hope it does make sense, but don't now think this means like everything will be a snap. It doesn't, but we'll get there. You get my point. Anyway, you're all being very patient. You're being very understanding. We'll all get there together. Thank you all for such participation. And yeah, I'm gonna stop the recording. I'll hang out if there's any quick questions, but then the other class is coming in. So yes, thank you. And thank you, Carl. All right.